Okay, today we're going to learn lesson 6 of unit 3, equivalent forms of exponential equations. First of all, let's have a look at today's learning goals. After this lesson, you should be able to express exponential functions and expressions in different ways by changing the base. Understand that changing the base of one or more exponential expressions is a useful technique for solving exponential equations and solve simple exponential inequalities. So today there is not much knowledge we're going to learn, but some exercises. We're going to introduce these techniques by considering 3 different types of questions, okay? So first of all, I'll give you 10 minutes to think about these example questions, okay? And after that, we'll have a look at the solutions together. All right, so let's have a look at the solutions together. This question asks us to express the following expressions in terms of power with the base of 2. So first of all, 8, apparently 8 is 2 raised to the power of 3, right? And next one, 4 to the power of 3. 4 is 2 to the power of 2, right? And then to the power of 3, this is actually 2 raised to the power of 6. And question C, note here 16 is actually 2 raised to the power of 4. And then raised to the power of 1/2, then multiplied by 32. 32 is 2 raised to the power of 5, right? And then to the power of 1/5, and then to the power of 3. So this is 2 raised to the power of 2 times 2 raised to the power of 3, which is 2 raised to the power of 5. Okay, question D. This may seem not straightforward at the beginning, right? So basically we want to find 2 to the power of x, which equals 12, right? And we need to solve the value of x. So note here we can find log base 10 of both sides. That means log base 10 of 2 raised to the x equals log base 10 of 12, right? And this tells us that x times log base 10 of 2 equals log base 10 of 12, which gives us x is actually log base 10 of 12 over log base 10 of 2, right? So we can express 12 is actually 2 to the power of x. And we have already known that x is log base 10 of 12 over log base 10 of 2, right? So in this way, we have expressed number 12 in terms of a power with the base of 2, okay? All right, you can also check the solution in this lecture slides. Okay, all right, so let's have a look at another example question. Solve a equation by changing the base. Solve each of the following equations. Okay, first of all, I'll give you 10 minutes to think about this question. Right, so let's have a look at the solutions together. Question A. In order to solve x, it's better to change the base to the same number, right? So note here, the left side is 4 raised to the sum of x plus 5. The right side can be rewritten as 4 to the power of 3, right? And then to the power of x. So this means 4 to the x plus 5 equals 4 to the 3x. So now the base number are the same. That means the exponents must be the same in order to achieve the equality on both sides, right? So that means 2x equals 5, and x is, of course, 5 over 2, right? Okay, next one, question B. Again, in order to solve this equation, it's better to change the expression using the same base. So note here, the 4 can be rewritten as 2 to the power of 2, right? And then to the power of 2x. Right side, 8 can be rewritten as 2 to the power of 3, and then to the power of x minus 3. This is equivalent to 2 to the power of 4x equals 2 to the power of 3x minus 3 by 3 is 9, right? So note here, the base number are the same now. In order to achieve equality on both sides, we must ensure that 4x equals 3x minus 9, right? And therefore, x can be solved to be minus 9, right? Okay, you can also check the complete solution on this lecture slides. Okay, so next, as I mentioned, we shall also be able to solve simple exponential inequalities after this lesson. So now let's have a look at an example question that involves exponential inequality. Please solve the following exponential inequality: 81 raised to the x minus 2 less than 27 raised to the power of 2x plus 1. Okay, first I'll give you 10 minutes to think about this question. All right, so let's have a look at the solutions. Actually, there are two methods to solve this question. First, let's have a look at method 1. Okay, note here, 81 is 3 to the power of 4, right? And then raised to the power of x minus 2. And 27 is actually 3 raised to the power of 3, right? And then raised to the power of 2x plus 1. And then this is equivalent to 3 to the power of 4x minus 8 less than 3 to the power of 6x plus 3, right? And from here, as you can see, 3 as the function y equals 3 to the power of u is increasing function, right? So that means in order to have 3 raised to the 4x minus 8 less than 3 raised to the 6x plus 3, we need to ensure that 4x minus 8 is less than 6x plus 3, right? These two expressions are equivalent, which is equivalent to 2x is greater than minus 11. Therefore, the solution is x is greater than minus 11 over 2. Okay, all right, so let's have a look at method 2. Again, the expression can be rewritten as 3 raised to the 4x minus 8 less than 3 raised to the 6 plus 3, right? And this time we can consider using this function, y equals log base 3m, right? This is also a increasing function. So we can find the log base 3 of both sides. So that means log base 3 of 3 raised to the 4x minus 8 less than log base 3 of 3 raised to the 6 plus 3, right? And this is equivalent to left side is 4x minus 8 and right side is 6x plus 3, right? Which is equivalent to 2x greater than minus 11. And therefore x is greater than minus 11 over 2. So you can choose either method you like to solve this question, right? Okay, so these are the techniques we have learned so far for today. These are the fundamental to solve exponential equations, which we'll be exploring further tomorrow, okay? So let's make a summary of today's lesson. After this lesson, now you should be able to express exponential functions and expressions in different ways by changing the base. Understand that changing the base of one or more exponential expressions is a useful technique for solving exponential equations and solve simple exponential inequalities. All right, so the rest of the time is for you to complete and submit today's homework before the deadline, okay?